Welcome to a new test and teardown video. This time it's a Philips 5193 programmable synthesizer function generator, 0.1 millihertz to 50 megahertz. And it's quite modern, fully computer interface and remote, and you input everything on this, dial this and dial that and input this and that. Not the old styley turn this and anything analog. No. Here is everything digital. I also got another one, the 5190 from 1979. You should also see this. Definitely clear to see what happened over a few years of progress in programmable synthesizers from Philips. And this one is, as you can see, really big. So it's 44 centimeters deep. I mean, it's really big. It's 10.5 kilos heavy, and it's using 105 watts mains supply, and that is very good, useful information from the manual. So I'll definitely check this out. And the clock oscillator reference here is better than 1 ppm per year. So it's a very good reference unit. And I just checked out their bulletin in the manual. This one was a top of the line, their top best model when this one was released, and it got 8-digit of resolution. And so it should be really nice. I found this in a dumpster. Really? Yeah, I was going past one of those electronic waste dumpsters, and there it was. So yeah, well. So here is the back, modern IEC connector, and here is the fuse, 630 milliamps. And that is the full model number, serial number, and everything. And here again, 105 watts. There's a power supply regulator and a fan. Oh no. I got some inputs, pen lift and sweep and all that. And of course you can use it for sweeping pen plotters. This also reveals a little bit about its age. Modulation, external clock and internal clock. So this will be an output. And but it says inputs. Really? And IEEE interface. So here's the first little thing. Of course you need to remove the little feet, I guess you call these, and then untighten the screws through this hole, and then flip up the outer casing. But my God, this thing is dirty. So this fan, of course, sucks in all the air, and there isn't any filter. So it just sucks everything in and coat everything in a thick layer of dust, as you can see. So I better go and give this a big amount of compressed air and make it nice and presentable. But first I just wanted to have a little quick look about. You can't even see. Oh my God. Oh, we got a little CPU and some memory and a. Oh, this is. No, it's actually mounted. This is scary stuff. And there's a little note. Oh, so the battery was changed in 92 or something. So that was good with a little bit of cleaning, and it's nice and shiny. Oh, look at all those ICs and counters and gates and flippity floppities and thingies. And the CPU is an 8031, copyright 82. So this tells me a little bit of the age, of course. And the software is, of course, in an EEPROM, 128 kilobit EEPROM. And by the way, I tried to check out all the different gates, and I think it's down here where I found, yeah, 84. I think this is the highest number I could find. See, 84, yeah. So that tells me this unit was most likely from 84. And also this big circuit board, I removed the little screws here because I want to try and flip this so we can enjoy the big circuit board underneath in a second. But first I want to try and open this little shield box, and I think there's a little screw here, so this is maybe, yeah, this is how you open this one. So that is absolutely beautiful. Look at all those transistors and resistors and fantastic things. So what exactly is going on here? It looks like a little bit like an attenuator, right? So it could be something related to that. It can also be the sine wave converter, but I will think, let's get back to that. So this battery is from 91 and it was replaced in 92. And there's 17 millivolts left on that one. So I just, I just have to remove it. Nice little lithium. And they glued it real good. Damn it. How do I take this out? Okay, here we go. That is some splatty splat. So that flips up real nice, and there's an extra shield towards the base circuit board, and look how big that is. And this is some of it, and this is the rest of it. Of course, that will be the power supplies and extra capacitors for the big rectifiers. See, we got the rectifier bridges right there. And there's another one down there, the big one. And then, of course, we got some low power regulators as well. But in here, we got all the analog goodies. Classic Philips with all those relays. They just love those little reed relays. And a lot more analog. And this is, of course, where all the analog stability is, and there's some heat sinks, and this I bet is the final output stage, because this is where we got the BNC connectors. See, there'll be some output driver transistors and all that kind of stuff, and I really hope that I guess right. That is where we'll find the clock oscillator, so we better open here and have a little look, right? Yeah, I think this is the clock oscillator, and we got a little bit of gates and some counters in here, so that has to be related to that, and probably some internal external flip over kind of system. Maybe we can get inside this little box. So this is the rear side. Oh my god. This circuit board is full of all sorts of little modifications or repairs or improvements or whatever it is. Is this really, look at that. Is this factory? I mean, I don't know. This is the first one I see, but I think it is good to document all this so that you will be able to check it out if you got one, and then you can see all those little mutts and whatnot. They even tried to hide it a little bit using green wire that is harder to see. Yeah, let's try and see if we can get inside this little fancy shield box here. Well, it's always a lot of fun when I guess wrong. There's no crystal in here, right? So where is the crystal? Because Look at that. We got some op amps and some fancy smancy parts, but no crystal to be found. So I will continue my hunt in here, but I think this is just the analog output and things related to that. So, well. So at least I guessed right here. So this is of course the output amplifier and the attenuator system, using all those relays and all that kind of stuff. And then with the heatsink on here, we got some more driver transistors there, and all the pre-drivers and all the analog stuff related to the analog output, because we got all those transistors here running in push, pull, parallel and all that kind of stuff to make it really, really fast. So out here we got another set of output, and that's of course the TTL output drivers for all that, right? So I think that is how it is. Yeah, so I better get everything back together here. It looks nice and fine, so I'm not going to do a lot more about that. But look at all that electronics. So let's try the first power up, because I don't really find anything blown up real bad. So let's see. It is using 115 watts. And could of course crank down the voltage to 220. It was supposed to be 220. And let's see, then it is 107. So everything is very, very close to being normal. So we hit local, sine wave, 1, start. Okay, 1, see, not entered. 1, 2, 3, 4 hertz. We just enter hertz, and it's entered, right? So we need to have a output. Let's see. Off. Modulation is off. Voltage peak. See, here's what we need to do. 1, enter, and here you go. It is working, and it even says 1, 2, 3, 4 on the. I mean, an oscilloscope isn't really super good for accurate frequency, but it's still quite good. So you click here, and let's try 10. Enter. Yeah. I kind of like this input method. It's really nice and easy to use. Let's grab the camera here from the holder and have a nice little look at that. So here's the frequency, 1, 2, 3, 4. I just powered it up, ice cold and everything. And look at that, 1, 2, 3, 4. Holy moly, that is goody goody. Oh, look at that. The output is also exactly right. So we got 2 volts per division. I didn't load anything at all because I think it should be open. No, it says 50 ohms. So here's the output again. Let me show you a fun thing about the impedance. So in 1 mega ohm at 1 kilohertz, I mean, of course you get 5 divisions. I have now 5 volts peak to peak output. So if I, of course, hit the 50 ohm impedance loading, I get exactly half of that. And then all you have to do is, of course, hit the generator like that and say 10, and this way compensate, because of course the output impedance is 50 ohms, and when you're loading with 50 ohms you get half, and that is just a completely normal way that things interact with output impedance and loading, so no big deal. It is just really easy to use. I've set up a linear sweep. I can click set up the time. I can set up continuous or all sorts of things. Start and stop frequency, you just dial them in, and then here it shows the time. It shows actually everything. So at the moment we see this sweep and it's running really nice and smooth, and then it just starts again. I am just really happy about this unit, I gotta say that. Okay, the fan is probably a little bit annoying, but what 100 watts, of course you need a fan. There's like 8 million ICs in this one. And you can't really change anything when it is running like this, see? I can't click the time, I can't click start or stop or anything like that because it is running in continuous. So all I have to do is hit single, and now it's done. And then I can change the time to, for example, 1 second, enter, and then back to continuous. And now it's going to go a lot faster. And let's try and stop that. And then I can of course change the waveform. So if I want square wave instead of sine wave or what, oh, then it goes, aha, then it can't sweep. And then back to sine wave. So we got some blinkety, no, you cannot do that, oopsie. Of course you could also read the manual and figure out all these things, but I think it's a lot more fun just to experiment. There's also a lot of limitations in the software. You can't really change between the different waveforms if the output frequency is too high. See here, I have a much lower output frequency, and then we can change between different waveforms and all that kind of stuff. And we can do a little pulses, positive and negative, and all the fancy things. But if you have a too high frequency, let's see, 1, 2, 3, 4, 5, 6, 7, 8, for example. And then if you try and poke around with the different waveforms, then you get a blinking start because your frequency is too high. It is that easy to understand the user interface. It's just blinking whatever it's not happy about, and then you can go back to sine wave, and then it will go steady again, and then it's not complaining. So this also, this not entered is also a little error warning. So that is really a good dumpster dive find, wouldn't you say? And it just works. All I did was a little bit of cleaning. I don't know, I think I started the video about talking about the 1 ppm accuracy reference oscillator and all the yada thingies. I think my model here is the cheaper one without this fantastic reference oscillator, because in my unit there is just a normal crystal like that. It's not even in an oven or anything like that. So what do you think? 1 ppm per year? Yeah, right. You need an oven and all the fancy bits to do that. But how far away is it really? So what I've done here is, you're looking at a GPS normal up here. So that is as accurate as it can be, right? As accurate as I will be able to manufacture a signal. And the other one here is the output from my generator. And I can of course try and adjust the crystal. So just to prove I'm right about this crystal, what happens if I touch this one? Oh, you see what I'm talking about? So that is in fact the reference oscillator. See? Aha, it is likely I will be able to adjust it, but this is very little when it comes to ppms and all that. I mean, what you see here is a 10 megahertz signal, and how many cycles is this one sweeping? It's not so much. It's very impressive, to be honest. So after a little bit of adjustments, I think this is as far as I want to worry about this for today. I think we are back to, I mean, if this one is flipping 1 phase per second, you know what we're talking about? 1, 2, 3, 4. It is 1 out of 10,000, so it is 0.1 ppm, right? Wouldn't you say that is how you do this? So let's see if it will still be this good in a year. Well, just wait a little bit and it's gonna be better. Of course, the idea is you should keep this completely closed and you should warm it up for hours and you should do many things. That is a little bit more than I wanted to put into it, but so far I think I have a very good unit, and I think I just want to end the video right here and say thank you very much for watching. Bye bye.